Hello everyone. So welcome back. This is part 7 of 2026 being consistent. And as discussed in last video, that was a call basically whether I have to start the Spring Boot course or AIML course. So based on the responses I received offline, not online, many online, there's just one comment. And yeah, we'll discuss that later on. But yeah, what I personally feel as well is there is not a single dedicated course on YouTube which will cover all the concepts from the roadmap from beginning till the very end. So we are going to do that and we ensure we cover each and every topic as much as in detail. And more important, what I want is that at the end of this course, you should have your brain functioning in that direction as well. Like you are not bound to that particular course segments or the projects which you are going to make, but you should be more like you are open to any changes, any type of models that you have to build, or any type of the changes that you have to incorporate in any of your upcoming projects. So our main focus is to build the logic, like how to use ML models, how to build them from the scratch, how to build AI models, and how we can effectively use them. So that will be our goal over the upcoming months, and as we cover this course from the scratch. So let's start with it. Okay, so the something which we have to cover before starting our learning of AI, what is AI, what is machine learning, how we are moving ahead in that direction, what is deep learning, data science as well. We are going to cover ML loops or whatever course we are starting. So your basics should be very clear before doing anything. So let's start with that Venn diagram, and there are certain terminologies of which you should be familiar as well. So let's start with what is deep learning, machine learning, AI learning, how they are different from each other, and how how to learn them in a manner like in a correct sequential manner, which we can say. So let's start with basic of machine learning. So as the name suggests, what is machine learning? I will write them down as well. We'll share the notes with you. ML. So what we do here is just as simple. From ML machine learning, basically we enable the machine to learn from its outcome. It's just that simple. What do you mean by machine learning? Uh, we are basically enabling the machine or any model or device to learn by itself. How it will learn by itself? It will, like you give it some question, it will predict some output. And then either you validate that output whether it is right or wrong, or the machine itself validated output from the environment. Based on that, machine learning is also categorized into several categories, which we are going to cover. So there are basically three categories of machine learning. Uh, those who have taken this, like they should be familiar. Supervised, unsupervised, and reinforcement. Yeah, spelling is wrong. Sorry for that. Okay. So what is supervised machine learning? Supervised machine learning, as the name suggests, yeah, it is being supervised. Who is whom is supervising the machine in its initial stages? Humans. Like humans are validating the output of the machine, whether it is right or wrong. Supervised and output is validated by humans. Okay. Unsupervised, opposite of that. Not supervised. Learn from its own output. Okay, now what is reinforcement? So, okay, before learning reinforcement, you have to understand the main difference between supervised and unsupervised is in supervised, like you are not telling a machine whether its output is right or wrong. You are giving the machine the correct output, and then the machine will check from the error. Okay, how much deviation there is from the correct output. That is supervised ML. And unsupervised ML, it's not like it's learning from its own output by itself, whether right or wrong. These both are reinforcement from the wrong. So unsupervised is basically grouping or clustering. Like it receives a large amount of data, so it doesn't know what is the right value it will have to predict. So what it does is it will group the similar kind of data, so so that it is easier to perform operations on that data. That's basically comes under unsupervised learning. And what is reinforcement learning? It's basically reward or punishment type system. Reward, punishment. I have to mention that now. Given the answer. Basically grouping. Uh, yeah, reward punishment type system. So what happens here is, let me take you. Uh, what will happen? So, yeah, how to learn from anything you wanted to learn from the documentation. You can try for Kaggle, it's basic for ML. So, like these are basic terminologies. As we go on into depth, we will cover like what should be our roadmap, should be the pattern which you're going to follow, and everything. So don't worry about them. Just focus on the theory. This theory might not sound like it's very interesting as well, but it will comes in handy when you go into the later stages as well. There are three types of basically ML. Okay, yeah, I know what I wanted to show. Let me just open supervised ML. Go through the images and take an event diagram. Label data. Label data is what you get. How do you categorize the label data? Like this is circle, this is rectangle, this is triangle, this is label. These are the labels. You will fed the label data into machine, and based on that training data, it will predict a model, and then you provide the test data, which also have labels, like based on those label, and then it will predict like what whether it is triangle or circle. It's just very simple. You can take from any images on the medium unsupervised ML. Um, okay, yeah, that will be nice. Yeah, input raw data, like raw data, no labels, anything. You just give it a lot of amount of data, like millions of data from the business flowing in real time. What machine learning do? It will interpret, apply some algorithm, cluster it. Like there are SVM kernels as well. SVM, yeah, there are various clustering techniques as well. And mm, yeah, based on those clustering as well, you can categorize that data into different kind, like red into red, green into green, black into black, like grouping the similar kinds of data. So all the red kind of data will be some of the similar type. So that becomes that eases the operation while you're handling with like millions of data, 10 million, 20 millions, like a single API hit in a single day. So if you have to deal with that much amount of data, then you also require unsupervised learning. And if it comes to reinforcement ML, we can take the diagram like input raw data, environment, reward, and punishment. Simple. Like agent will predict something, and from the environment is basically it can be anything. It can validate its own output from the results. It can be human interaction, anything doesn't matter. So it's just basically reward punishment type. So this is the basic of ML. Like what is machine learning? What are the types of machine learning? Why do you need it? Yeah, that's a very important thing. Machine learning is the foundation of AI. So if you how okay, like what is AI? Artificial intelligence. How will you incorporate the intelligence in anyone? Like let's say you have a little baby. How do you incorporate the intelligence in that little baby? Like by making it learn from its mistakes, from feedbacks, from its actions, like it will perform some actions, and you dictate it like don't do this way, there's a better way of doing that. So that's how like you prepare a baby to learn. So it follows the same pattern in machine learning and building AI agents from scratch as well. Like how you want to train your machine in from the data, so that it can learn what is required. Okay, now let's go to roadmap. Here comes the difference. What is an ML engineer? Machine learning, you know now what is ML engineer? ML engineer is basically that deals in machine learning models. That's a very good difference. What is an ML engineer and what is an AI engineer? Like most of the people confuse those terminologies as well. Like they confuse what is AI with ML as well. So machine learning is basically like enabling your machine to learning models in production environment, as you can see. And AI engineer, on the other hand, has a broader scope, like of entire AI systems. Machine learning is like you are teaching your machine what to do. AI is basically like getting the output from the machine. Okay, now you've completed your learning. Now come, let's do this task for me. So yeah, that's a very handy difference. You can do like you can watch the videos as well on that. You can read a documentation as well on Medium or anything. It will be good enough like to understand the basics of it. Skills and responsibilities. For machine learning, these are some difference. Like you must be good with. Okay, now there comes the prerequisites as well. Not before starting this, we will covering that. But okay, for machine learning, what you should know Python, you should know some of like Python libraries, and you should be good enough with mathematical fundamentals. Like we have to deal with them a lot. This is just maths. And why maths comes in handy when you build ML models, we will cover those topics as we go later on. Derivatives, chain rule, derivation, gradient, like you have to good with maths. Okay. So this is just a part of introduction. And for today's, I will be just like covering what we're going to cover in this entire course in detail and some starting points as well. Okay. Like what is linear algebra, matrix operations, scalar vector tensor. Okay, in linear algebra, matrix and metric operations, everyone should be familiar of scalar vectors and scalars and vector. Science students should be aware of what are scalars and what are vectors. Vectors have directions, scalar doesn't have those. Singular value decomposition, SVD. Okay, yeah, this is a simpler topic. Inverse of matrix determinants. This is a this is just calculation part. Eigenvalues, diagonalization. It will we will try to wrap it up in a single video if we can. Then we'll move to calculus, derivatives, partial derivatives, simple topic, chain rule. Okay, yes, there are multiples like what, how to derivate them, gradient, Jacobian forms. You must have covered in maths too, I guess. Maths 2, maths 4. It's not that difficult as well, and we'll be covering that. Discrete mathematics is something which can take time, like graphs, logical statements, like that implies not if you're familiar with them. But okay, statistics, it is the easiest part in maths. This is what we feel. Like statistics and probability, um, you can cover like an instance. You just have to memorize some formulas as well. For probability, it's very simple, like Bayes theorem, probability of A union B upon like simple formula. I don't remember the exact one, but okay, yeah, we'll see. And random variable, the yeah, one minus cos probability PDFs, type of distribution as well, probability we can do them. So 2 or 3 videos will cover just basically mathematical introductions, what we will be requiring for those topics. These are not covered in yes, no. So you can take some documentation. I will provide the link as well to them, and you can try solve some simple questions as well. Make sure you understand the logic behind what is the use of mathematics in machine learning, how we are using it, how this comes in handy while we build an ML model. Okay, so for probability, it's very simple. Like whatever ML predicts, it's just a probability of something. Like if we give a dog image to ML, like ChatGPT, and ask its probability, like it will tell us this is 99%. If some not sure, 99.99%. So that's how it deals with probability. most of the times. Most of the times, while what ChatGPT or any AI model does is it will give you some ambiguous answer. So the reason behind those answers is the model is not 100% sure. Based on that 60 or 70% majority of the probability, it will give you the answer, and that majority might be wrong sometimes. So that's why it is said like please don't trust AI fully. Review it before the use if you read them. Instructions as well. So um, yeah, gradient Jacobian statistics. Statistics is like basically computation. How you want to compute how are different types of activation function works. Graphs and charts as well. Descriptive statistics and those things. Calculus and linear algebra, great use. So we will cover them in 2 or 3 topics, and then we will begin with Python, Python fundamentals, how much Python you should be knowing before starting machine learning, and how much you can rely. Like, okay, I will learn those stuff as the progress goes on and on. So there will be time like while you are learning something, you might stuck and think, okay, I don't know this thing fully. So there are only 2 approaches in that. Either you research, and understand that thing. And while researching, what happens is you learn the 3 things that are coming way ahead of that and as well. So either that way or like, okay, for some of the stuffs you can rely on like, okay, this part might be covered later on. This part I will get it done later on. You note it down. You think it will if it will be if it is covered in the later parts of the video, later parts of the course, I will do it later there and then. If not, fine, I'll do it myself. So that mindset you have to think while you're learning something. You don't have to miss an important segment, but you don't have to like rely. Okay, you don't have to be blocked. There shouldn't be a deadlock as well. So you don't have to rely uh, on any one segment. More of like, okay, if I'm not understanding it right now, I'll try to cover it in the later section. So Python basic syntax. Okay, essential libraries, NumPy, Matplot. These both will be going with Matplot. NumPy and Pandas, everyone we have done. Then comes the databases, data formats. Mostly we will deal with CSV while learning data. Parquet is uh, like it's used for data science, and while you're dealing with very large data, it is a very handy as well. We'll try to cover it as well. Data clean techniques, machine learning, types of machine learning, self-supervised, semi-supervised. These are all just derived of these two. Scikit-learn, supervised learning in details, these regressions, unsupervised clustering, dimension reduction, PCA, okay, reinforcement learning as well. Then these are some simple topics. Most of them are theory, but if you deep dive into their like formulas, these are essential things. Like if you try to read them online, you will get the meaning of them in like single line or two. But the real part comes what's beside them. What mathematical formulas, how they're doing that, like what they're supposed to do. How reinforcement learning is actually giving the punishment reward or system to its model. How supervised learning adding labels, how unsupervised learning is dealing with unlabeled data. So while we go into depth with the models and actual mathematical implementation, that's the that's the place where crazier stuff starts to happen. So that will be fun to do. Then come with deep learning, and then deep learning libraries, TensorFlow is like very much used, CNN and attention mechanisms, autoencoders, GAN. So after that, we will cover with AI engineer envelopes and then also them. So yeah, it will be fun. We'll try to first cover this and then we'll go to the like next of the courses. Okay, so with all the details that you're going to cover in the machine learning course as well, start with the very first topic introduction. Uh, the rest of the mathematical foundations and all those topics will start from the next videos as well. And based on introduction, what is an ML engineer, ML versus AI engineer, and skills and responsibilities of the both. Okay, so skills and responsibilities of ML engineer you can get anywhere online. But still, okay, key skills include proficiency in programming like Python, statistical concepts, which is basically maths, experience with ML frameworks. Okay, now if you come with experience with ML frameworks, it has to be some really good projects as well. If you want yourself to get shortlisted in the internship or job roles dealing with ML, responsibilities often comprises data collection and pre-processing. Okay, how data handling is essential while you deal with machine learning models as well. This is something that I've covered in my second video, yes. Uh, like why it is essential because the data you're going to provide your model, you have to validate that first, whether it is correct or wrong, right or wrong, whether it's within the range the model can process. Like the model can process the data between 0 and 1, most of the models. So you have to determine the model cannot process the textual data as well. These are all models that are built on mathematical functions. So you have to normalize and stabilize the data so that your model can process it. Then comes model selection. Like there are for a certain task to be done, there are more than hundreds of models available, like which do similar kind of tasks. So you have to pick out the best one. Like if you want your house prices to be get predicted, you don't have to use the classification models or clustering models. You have to use the regression types one. So and those regression type as well, which model you have to use, which advantages and like what we say the properties of the model align best with your interests, so that comes in handy while doing model selection as well. Training data set, you have to divide like 70-30 rule. There is 80-20 rule, right? 80% data for training, 20% for testing, and so on. Performance validation is very essential. Like if you're training your model, you have to be 100% sure. Okay, like I have trained this model on those stuff. Like what is the outcome, what is the accuracy, what is the F1 score, like these are certain terminologies which we will cover like moving forward. And what are like how I understand whether the outcome given my model is like how much deviation from the correct result. You have to validate as well how you can improve. Continuous model improvement, like back propagation is one of the most, what can we say, common one, and most taught ones also. Like of all the students must have studied there in the academic as well, like how you do the model improvement as well. So these are the responsibilities that you have to deal with. Okay, let me write them down in one place. Responsibilities. Data collection, pre-processing, training, performance validation, and continuous model improvement. Like you have to deal with all four of them. And skills, uh, proficiency. Okay, yeah, this is something I also have to write that down. Skill, like Python, and one most common is R. But we will be heavily relying on Python for that. Strong understanding of statistical concepts, that is maths basically. Experience with ML models, we can say projects, and knowledge of ML models in depth as well. So these are some ground skills required. Like these each skill might have two or three subparts in it, like mathematics, what I've told you, and so on. So we will be covering each of those type as we go ahead and so on. And okay, yeah. For that one comment, like whether I should start the DSA series as well, we can think of it, but there are certainly like more better teachers out there in the YouTube that taught DSA way better. Like I would highly recommend trying watching Kunal Kushwaha DSA course. It's super beneficial and it's like great to learn. I've started from there as well. And then you can like once you finish that course, there are certain key topics left, which you can cover them by yourself as well as you move ahead while dealing with questions, like reading newsletters, reading some solutions as well, or you can watch like for these concepts, some videos available online as well. So yeah, but it is really good for basics. You can try and watch that as well if you like really wanted to uh, what to say to start with DSA. So yeah, we'll be going forward with ML topics and this was seventh video what we have done. We'll be turning off our daily updates so I can give it out like orally as well. So aside my internship, I've started with something kind of freelancing as well. Let's see how that goes. I'm kind of excited for that. And yeah, based on my learning, I'm nearly like on the end of AI path as well. Machine learning is something I've completed, and for what do I have to cover? Like, yeah, based on my projects and DHR line, some progresses are still going. The next update of DHR line will be really excited. Stay tuned for that as well. You can like learn how to contribute as well on the open source. My GitHub link is shared on my LinkedIn as well, which I've connected. You can go through and okay, for machine learning, you can also start the initiative like capture the screenshots and you can post your learnings online as well. Hashtag engineering with engineering with Dhruv. So, okay, this is all about machine learning and skills and responsibilities, what you have to achieve. And yeah, you will be achieving like if you follow this course from starting to ending. We will be covering each of the topic in depth, solving questions. Moreover, like your thought process will be enhanced, like if you go from each step to the later one as well. We'll be covering each that. We're going through Kaggle, participating in some concepts as well, building notebooks and everything. We'll start with the setup as well. So stay tuned for that. Uh, and yeah, continue learning and doing this. Practicing it regularly, more importantly. In the initial stages, for maths, you can do some of the questions, but for Python libraries, data formats, you have to practice at least a little segment of the code or something like regularly. You have to revise weekly and practice regularly for both maths and Python until you're proficient in them, until you know like how to use them, where to use them without thinking much for a model. So till then you have to practice them on the daily basis. Yeah, this is all about Funable starting. So please like, share, comment, and subscribe, and we will cover the later topics in the next part as well. Till then, take care and good night. Bye bye.